A rational inequality is an inequality that contains a rational expression. These inequalities have solutions that are in the form of either a number line graph or interval notation. I will show both solutions. With these solutions, you have to be mindful of extraneous solutions, meaning solutions that will cause division by zero. So if you have something that's extraneous, you need to get rid of it because you cannot have it as a solution. So we're going to solve the rational inequality 3x minus 1 divided by x plus 4 is greater than or equal to 2. Now this one is not with a 0 here, so we're going to have to do something a little bit different. What we're going to do is we're going to set it equal to 2. So 3x minus 1 over x plus 4 equals 2. And we're going to solve this. So I'm going to multiply the x plus 4 up, and I'm going to get 3x minus 1 equals 2 times x plus 4. Distribute the 2 across. 3x minus 1 equals 2x plus 8. And now I'm going to solve for x. Subtract the 2x over, and I'll just get x. And then I'm going to add the 1 over, and I'm going to get 9. So one of my answers is going to be dealing with 9. Now, just like with the others, I take the denominator, x plus 4, and I set it not equal to 0 because I cannot have whatever this equals 0 for. So subtract 4 over, x is not going to equal negative 4. So I can have a 9 and I cannot have a 4, but these are the numbers I need to work with. So what I'm going to do is I'm going to draw my graph here, negative 4 and then 9, and I'm going to put a not equal to line underneath this, or symbol underneath it, just so it reminds me that it cannot be negative 4. So now I'm going to pick points. So something less than negative 4, which I'll say negative 5. Something in between negative 4 and 9, I'll just say 0. And something greater than 9, I'll just say 10. Got my points, so I'm going to take each one individually and plug them back into my inequality and to see, is it true or is it false? So first up, negative 5. So 3 times negative 5 minus 1 over negative 5 plus 4. And so when I work out everything, I'm going to end up getting a positive 16. And is that greater than or equal to 2? The answer is yes. 16 is greater than or equal to 2. So since it's true, big ol' check, because I know everything in that area is good. Now I'm going to use 0. 3 times 0 minus 1 over 0 plus 4. Going to do all the work here. I'm going to end up getting a negative 1/4. And is it greater than or equal to 2? The answer is nope. No, it's not. So I know everything between negative 4 and 9 is not true. Now I'm going to do 10. So plug 10 in, and I'm going to get 3 times 10 minus 1 over 10 plus 4. And when I go through this, I'm going to get, not a nice fraction, 29 over 14. And is that greater than or equal to 2? Now, if you're not sure, plug this into a calculator and see what comes out, but this is just a smidge over 2. So that makes this true. This is greater than or equal to 2. So everything in this area is A-OK. So now I have my sign graph done. I can graph this in on a number line. So again, I'll have my negative 4 and positive 9. And so I know everything from negative 4 to the left is true. And since it's not equal to negative 4, I know that this has to be a parentheses going this direction. And then I got 9 and more, so 9 to infinity. And because this is greater than or equal to, it will get a bracket going towards infinity. And now I can write it in interval notation. I know it's going to go from negative infinity to negative 4 parentheses, union, and then again a bracket, 9 to infinity with the parentheses. So here's my answer in interval notation.